In programming environment, there are three important terms: pseudocode, algorithm, and flowchart. When programmers want to develop the basic logic for their code, they often start by using pseudocode. This is a straightforward way of expressing what you want your code to do without actually using any coding languages. If you are interested in coding and programming, understanding pseudocode can be quite useful. As the name suggests, pseudocode, it cannot be executed on a real computer, even algorithm and flowchart. And what is important is there is no single syntax or standard for writing pseudocode. And why? Because a computer is not going to read the pseudocode to execute it. Although there is no broad standards for writing pseudocode, in certain environments we might encounter some preset standards or guidelines in writing pseudocode. It exists in various forms, although the most syntax is from popular languages like C, Lisp or Fortran. And the textbooks often use pseudocode in their examples so that all the programmers can understand them, even if they do not know the same programming language. So in the algorithm design, the steps of the algorithm are written in free English text. They may be as long as needed to describe the particular operation. The steps of an algorithm are said to be written in pseudocode. We'll start with the sequence structure. As you know, the sequence structure, the first type of control structure is sequence structure. This is the elementary structure. No conditions are involved in this. Suppose you want to design an algorithm for finding average of 6 numbers and the sum of the number is given. The input is sum and you are supposed to find the average of 6 numbers. So before writing the algorithm, we start with the pseudocode like this. Look at the pseudocode. Start, get the sum, average is equal to sum by 6 and output the average, stop. A sequence structure, one after another. All the statements will be executed one after another in case of sequence structure. So we have another example. To input 3 numbers from the keyboard and find the sum. So look at the pseudocode. Use variables sum, number 1, number 2, number 3. All are of type integer. You accept number 1, number 2, number 3 and sum is equal to number 1 plus number 2 plus number 3 and print the sum and the program. So we have another example which accepts 2 numbers and calculate sum and product, display the answer on the monitor. Use the variables sum, product, number 1, number 2 of type real. It can be of type anything, of course, integer or real. And look at the thing, display input 2 numbers, you accept number 1, number 2, sum them, print the sum, product and print the product and program. Decision structure or selection structure. So we have a choice of two alternatives depending on the condition. If you have more than two alternatives, we use case selection. Look at the flow chart. Condition true, do something. Condition false, do something. Condition true, do some task A. Condition false, do some task B. See the pseudocode. If condition is true, then do task A, else do task B. Else. The one before else is true, the one after else is false, always in programming languages. The same structure, we can write it in this way also. Condition true, task A. Condition false, do nothing. Look at the pseudocode. In this case, if condition is true, then do task A. In this case, if the condition is false, do nothing. So there are some occasions where we have many alternatives. So look at that simple example here. If A is equal to B, print A is equal to B. And the action is only taken when the test is true. So we have a logical operator is equal to. So we have logical operators equal to, greater than, less than, greater than or equal to, less than or equal to, and not equal to. Look at the logical operators. So I have an example pseudocode here. Use variables choice of type character and ANS number 1, number 2 of type integer. Choose one of the following: M for multiply, A for add, S for subtract. We have many options here. Accept choice. Input two numbers. If choice is M, then multiply. If choice is A, add. If choice is S, subtract. And display the answer. So we have compound logical operators. There are many occasions where we need to extend the conditions and that are to be tested. Often there are conditions to be linked. This is an example. So input an examination mark and test it for the award of the grade. The mark must be a whole number between 1 and 100. And the criteria is greater than or equal to 80 is distinction and greater than or equal to 60 is merit, and so on. Look at the pseudocodes. Use variables mark of type integer. If mark greater than or equal to 80, display distinction. If mark greater than or equal to 60 and mark less than 80, display merit, and so on. So we used only if statements here. So we have an option of using else statement also. Look at another example. A person is paid at top for category 1 work, otherwise pay is at normal rate. So if the work is category 1, pay rate is top, else pay rate is normal. The else statement provides a clear way of dealing with alternative conditions. If work is equal to cat 1, category 1, then rate is top, else rate is normal. So we have an example of if-else statements in implementing double alternative conditions. Look at that. If salary less than 50,000 then tax is 0, else if salary greater than 50,000 and salary less than 1 lakh then tax is something. So we have a case statement, repeating if-else statements a number of times, sometimes confusing. So we have alternate method. So we use the term case statement in this pseudocode. So look at the example. Use variables, category of type cat, input the category, accept the category. If category is U, insurance is not available. If category A, insurance is double. If category B, insurance is normal. If category M, something. Describing the insurance available according to a category input by the user. If, else, if. And this can be expressed using case statement. So use variables, category of type character and display input category, accept category. Look at the do case of category. Case category is equal to U, display insurance not available. Look at that case. Case category is equal to U, case category is equal to A, and so on. Otherwise, display entry is invalid, and AND case. Yeah, instead of using otherwise, we can also use else here. Repetition or iteration structure. Sequence structure, selection structure, and iteration structure. If the condition is true, do some task and go back to condition. You repeat it till the condition becomes false. Repetition structure. So we have repeat until, while loop, and for loop. Look at that repeat until. Repeat a statement or block of statements. We can have one or more statements until a true condition. Look at the example. Display enter the number between 1 and 100. You accept the number until the number is less than 1 or greater than 100. That is a condition. So if the number is less than 1, if you enter the number less than 1 or if you enter the number greater than 100, you will just come out of the loop. So we have another example. Look at that repeat. A for athletics, we have some options. You accept the letter. If letter is A, this is a survey to discover the most popular sport. If letter is A, athletics is equal to athletics plus 1 and letter S and so on. Until letter is equal to Q. So look at the condition until letter is equal to Q. So we have while loop. You check the condition at the beginning itself. While condition is true, a statement or block of statements will be, and while and while. Look at that example. While letter not equal to Q, accept the letter. So you enter whatever the character except Q. If you enter Q, then you come out of the loop. To print out each and every character typed until the character Q is entered. If it is not equal to Q, it accepts and displays. So we have another example. Square root of any number input until the number is 0. Look at the while condition. While number not equal to 0, you are finding square. It's not square root. If you are finding square, square is equal to number multiplied by number, square of the number. Keep on giving the inputs. Once you enter 0, you just come out of the loop. So we have for loop. When the number of iterations is known in advance, we use for loop. We use initialization of the variable as a starting point and a condition, and increment or decrement, whatever it is. Look at the pseudocode. For starting state, stopping condition, increment, and the statements, and for. Look at the simple example. N is equal to 1, comma, n less than or equal to 4, comma, n plus 1 display n and 4. So 1 to 4. The loop is repeated 1 to 4. So I have another example to calculate sum and average of a series of numbers using for loop. So how many numbers do you want to input? If your input is 5, you are supposed to enter 5 numbers. You are adding all the 5 numbers. You are finding the average of the 5 numbers. Go through the pseudocode.